Hello guys, sorry for posting and explaining late. Just know that on Thursdays I don't have enough time, so I'm gonna be posting it a little late, okay? So which of the following are properties of electromagnets? I'm really confused about this question, by the way, because we didn't take anything about electromagnets, but let me just explain some things about electromagnets for you. Just some key things you need to know about electromagnetics is that they are made of a current and an insulating core. Basically, they are magnets made from electricity. So for this question, what I'm going to do is that I'm going to choose the answers and then I will explain each one. So the three correct answers are that electromagnets stop being magnetized when the current through them is off. The direction of the electromagnetic current or field can be changed at will, and the role of the electromagnetic core is to increase its strength. Okay, an electromagnet is an electromagnet is a magnet that has electricity. So if we're gonna be having a winding current, this is true, but should we have an insulating core? No. Insulating core will not accept it will not take in the current, it will block the current, so then the electromagnet will not function anymore. Second thing, electromagnets are not permanent magnets, they are temporary magnets. So that's why the first two are wrong. Now, the next ones. Electromagnets stop being magnetized when current through them is off. Very easily. You remove the current, it won't work anymore because it is a magnet that functions because of electricity. Okay? Second thing, the direction of electromagnetics magnetic field can be changed at will. Because this is a magnet that we made out of electricity, we can definitely change the direction of its magnetic field, and we can also change the strength and all of this. Now, the role of the electromagnetic core, we have the core of the electromagnet is to increase its magnetic field. The core, which is the center, its role is to increase the magnetic field strength. So that's pretty much for question number 1. Now, question number 2. I'm just going to explain very briefly about temperature and sensation of hotness. Sensation of hotness, you can either feel hot or you can feel cold. How do you feel hot? Hot, you feel the energy entering your body. This is when you feel hot, okay? But when you feel cold, this is the energy leaving our body. Okay, then temperature is what? It is the degree of hotness of a body. So these are just quick definitions based on the question. They need temperature and the sensation of hotness. So a person experiences a sensation of coldness when heat flows into their hands? No. When the heat enters the body, then they will feel hot. The sensation of hotness is a quantity that can be measured? Definitely not. If you touch, for example, a stove or something hot, for example, when you're drinking tea and you touch the cup, can you measure how much heat you are feeling? Definitely not. The sensation of hotness can be used to accurately measure temperature. No, you cannot use the sensation of hotness to accurately measure temperature. For example, if someone has a fever, if you touch their forehead with your hand, you cannot accurately measure what is the temperature of their body. You need to use something like a thermometer, stuff like this, okay? Then, temperature is the degree of hotness of a body. This is true. And then a person experiences a sensation of hotness when the heat flows into their hands. This is true. They experience coldness when the heat is flowing out of their hands. Now, whenever we're doing an experiment, especially in the calibration, we have hazards. We only have 3 hazards, which are extreme heat, okay, toxic elements, which could be like alcohol, mercury, stuff like this. And then finally, fragile glassware, because the glassware could break. So these are the 3 hazards of calibrating a mercury thermometer. Okay, it is extreme heat. It is the toxic mercury. So look, we have mercury thermometer. Do we take toxic steam or toxic mercury? Definitely we take toxic mercury. And then finally we have fragile glassware. Question number 4. Okay, here I'm gonna do a quick summary, a brief summary about 3 laws we have. We have Boyle's law, we have Charles' law, and we have the pressure law. Boyle's law. What does Boyle's law state? Boyle's law states that at a constant temperature, so we have constant temperature, okay? The volume is directly proportional to the inverse of the pressure, or you can say that the volume is inversely proportional to the pressure. If we're gonna draw the graph, this is gonna be the volume, and this is gonna be the pressure, and the graph of volume and pressure will look like this. However, if we're gonna draw the graph of the volume and the inverse of the pressure, it will be a straight line passing through the origin. So Boyle's law states that at a constant temperature, the volume is inversely proportional to the pressure and directly proportional to the inverse of the pressure. If you're gonna do a volume pressure graph, it will look like this. If you're gonna do a volume and inverse of pressure graph, it will look like this. So this is basically Boyle's law. The equation we can derive from Boyle's law is that P times V is equal to constant. So we can say P1 times V1 is equal to P2 times V2. This is Boyle's law. Now, the second law we have is Charles' law. Charles' law. So Charles' law states that at a constant pressure, okay, the temperature is directly proportional to the volume. If we are gonna draw it, okay, this will be your volume over here, this will be your temperature, and your slope will be a straight line passing through the origin. So at a constant pressure, the volume of the gas is directly proportional to its temperature. Temperature capital means the absolute temperature, which is the temperature in Kelvin. So if we're gonna get the equation of this rule, it's gonna be that volume over absolute temperature is equal to constant. So then we can say that V1 over absolute temperature 1 is equal to V2 over absolute temperature 2. So that is Charles' law. And now the final law we have is the pressure law. Okay? The pressure law states that at a constant volume, okay, the pressure is directly proportional to the absolute temperature. So if we're going to draw the graph, it will look something like this. This is the pressure, this is absolute temperature. It's a straight line passing through the origin. So if we're going to deduce the rule for it, it's going to be that pressure 1 over temperature 1 is equal to constant. So then if we're going to elaborate, we're going to get that pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. So now, if you remember from chemistry, we took this equation PV equals nRT. Okay? Here, in physics, we know that N and R are always constants. Okay? So if N and R are always constants, and we move T to the other side, we will get this equation P times V over T is equal to constant. So if we elaborate even further, we're going to get that P1 times V1 over the absolute temperature 1 is equal to pressure 2 times volume 2 over the absolute temperature, I know you can't see it, over the absolute temperature 2. So this was just like a quick explanation. So now, a fixed amount of gas is sealed in a rigid cylinder of volume 10 centimeter cube. Initially, the gas is at negative 73 degrees Celsius and 800 millimeters of mercury. In order for the pressure law, you remember the pressure law? The pressure law says that we have a constant volume, okay, and that pressure is directly proportional to temperature. So in order for the pressure law to be applicable on a fixed amount of gas, which of the following must remain constant? Definitely the volume must remain constant. Now I know they say select all that apply, but the only thing you can select is volume. Now they said if the pressure of the gas became 1200 millimeters of mercury, then let's find the new temperature of the gas. Okay? We have that the pressure, the initial temperature is negative 73 degrees Celsius and 800 millimeters of mercury. So negative 73 degrees Celsius, 800 millimeters of mercury. This over here is our temperature initial, but it is in degrees Celsius. So for sure, we have to change it to the absolute temperature, which is in Kelvin. So to change it from degrees Celsius to Kelvin, we are gonna add 273. So minus 73 plus 273, we are gonna get that the absolute temperature is 200 Kelvin. And now this is of course our pressure initial. Okay, so we know that the rule for the pressure law, or the pressure law rule, is that pressure 1 divided by temperature, the absolute temperature 1, is equal to constant. So if we elaborate it further, then pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. Pressure 1 is definitely, first of all, 800 millimeters of mercury over the absolute temperature at first, which is 200 Kelvin. It's equal to the pressure 2, which is 1200 millimeters of mercury, divided by absolute temperature 2, which we need to find. So you can do cross multiplication, and you will get that 200 times 1200, I write it here, divided by 800 is equal to the temperature final in Kelvin. So if we do it, we're gonna get 200 times 1200 divided by 800. So it is 300, but this is in Kelvin. Then do they need in Kelvin or in degrees Celsius? They need in degrees Celsius. So to change from Kelvin to degrees Celsius, we're gonna subtract 273. So 300 minus 273, you will get that it is 27 degrees Celsius. So the new temperature becomes 27 degrees Celsius. So now question number 5. A fixed volume of an ideal gas is kept at a constant temperature. If temperature is constant and we're applying what we are applying, Boyle's law. Boyle's law states that the volume is directly proportional to the inverse of the pressure, or that the volume is inversely proportional to the pressure. Okay, the rule then for Boyle's law is that V1 times P1 is equal to V2 times P2. So we have the initial pressure, so P initial, which is 200 kilopascal, and the volume, oh my goodness, and the volume initial, which is 4 liters. Notice, read, the pressure of the gas is then increased. So that means V final, or sorry, not V final, the final pressure, P final, is going to be the initial pressure, which is 200 kilopascal, plus the increased pressure, which is 300 kilopascal. So the pressure final is 500 kilopascal. Okay, so now we have what? We have volume initial, we have pressure initial, and we have pressure final. Can we find the new volume of the gas, which is volume final? Yes, by applying this rule over here. V initial is 4 liters multiplied by P initial, which is 200. It's equal to V final that we need to find multiplied by P final, which is 500. So if you bring it to the other side, you will get what? You will get 800 divided by 500, and then if you do it on your calculator, you are gonna get 1.6 liters. So in order to calculate the new volume, which law must be applied? Because we have a constant temperature, it is what? It is Boyle's law. Now the new volume is 1.6 liters. Okay, now question number 6. So on the Celsius scale, the ice point is equal to this and the steam point is equal to this. Okay, I'm gonna talk really quickly about the ice point and the steam point. At a pressure of 1 atmosphere, which is equal to 100,000 Pascal, which is also equal to 100 kilopascal. Okay, we have 2 points for water. We have the ice point, which is where either it goes from solid ice to liquid water, or from liquid water to solid ice. And we also have the steam point, where it goes from liquid water to water vapor, or from water vapor to liquid water. Okay, and the temperature for the ice point is 0 degrees Celsius. Okay, and the temperature for the steam point is 100 degrees Celsius. So at a pressure of 1 atmosphere, which is 100,000 Pascal, which is 100 kilopascal, the ice point, which is ice to water, water to ice, is 0 degrees Celsius, and the steam point, which is liquid to gas, gas to liquid, is 100 degrees Celsius. So here we have 0, here we have 100, and here we also have 100 kilopascal. So that was question number 6. Question number 7. Okay, this is nice. The absolute temperature of a gas at 150 degrees Celsius. 150 degrees Celsius. The relation between the absolute temperature in Kelvin, okay, it is equal to the temperature in degrees Celsius plus 273. So temperature absolute in Kelvin is equal to temperature in degrees Celsius plus 273. We need to find temperature Kelvin, so temperature Kelvin is equal to 150 plus 273. If you do it on your calculator, you are gonna get that the temperature Kelvin is 423 Kelvin. So the answer is 423 Kelvin. Question number 8. Okay. For a fixed mass of ideal gas, the relation between the pressure P and the volume V at a constant temperature. Anytime you see constant temperature, directly remember Boyle's law, where the pressure is directly, where the volume is directly proportional to the inverse of the pressure, or you can say that the volume is indirectly proportional to the pressure. So anytime you see a constant pressure, anytime you see a constant temperature, this is Boyle's law, where the volume is inversely proportional to the pressure. And then we can derive the rule that pressure times volume is equal to a constant. Here in physics and sometimes in chemistry also, they label constant as K. Okay? So for a fixed mass of ideal gas, the relation between the pressure P and the volume V at a constant temperature. So this is Boyle's law, where a volume is equal to the inverse, or is directly proportional to the inverse of the pressure. So that means we will get the relation that the pressure times the volume is equal to constant. If you're wondering how we get it, well, you can have it like this. You have volume is directly proportional to 1 over the pressure. If you bring pressure to the other side, you will get volume times pressure is equal to 1. 1, there is a K next to it, okay? We always denote instead of 1, K. So now the volume times the pressure is a constant K. Question number 9. The relation between the absolute value, scale T, and the Celsius scale O, I don't know what you call this, I totally forgot, is presented in the form that temperature absolute is equal to degrees Celsius plus 273. Very easy, okay? Anytime you're changing from Celsius to absolute temperature, which is in Kelvin, you add 273. Okay, now this is nice. A fixed mass of ideal gas has a volume of 8 meter cubed at 27 degrees Celsius. The temperature of the gas is increased to this while keeping the pressure constant. Anytime the pressure is constant, we apply what? Charles' law. Charles' law states that the temperature is directly proportional to the volume. So that means volume over temperature is equal to the constant K. So then we can expand to get volume 1 over temperature 1 is equal to volume 2 over temperature 2. So we will be using this equation over here. Let's look at, first of all, we have volume 1, which is 8 meter cubed at 27 degrees Celsius. Always the temperature has to be in absolute value. So to change it from degrees Celsius to absolute value, we're going to add 273. It becomes 300 Kelvin. Now the temperature of the gas increased to what? It increased to 177 degrees Celsius. So again, to change it to Kelvin, we're going to add 273. It becomes 450 Kelvin. Now to apply the rule to find the new volume, we're going to do volume 1, which is 8, over temperature 1, which is 300, is equal to volume 2, which we need to find, over temperature 2, which is 450. So then, by doing cross multiplication, you get that volume 2 is equal to 450 times 8 divided by 300. If you do it on the calculator, you are going to get that volume 2 is 12. So the answer over here is 12 meter cube. Question number 11. The pressure inside a gas container is 40 centimeter cubed of mercury at 127 degrees Celsius. The temperature of the gas is dropped to negative 73 degrees Celsius, knowing that the volume remains the same. So if the volume remains constant, then we're applying which law? We're applying the pressure law. The pressure law states that the pressure is directly proportional to the temperature. Then we can get the rule that pressure over temperature is equal to constant, and then we expand it to get the rule that pressure 1 over absolute temperature 1 is equal to pressure 2 over absolute temperature 2. So now let's locate. First of all, we have the first pressure, okay, which is 40 centimeter of mercury at 127 degrees Celsius. We cannot have it in degrees Celsius, we need it to be in Kelvin. So 127 plus 273, it becomes 400 Kelvin. Then the temperature is dropped. So the new temperature, so this is temperature 1. Then the new temperature, which is temperature 2, becomes minus 73 plus 273. So it is 200 Kelvin. Now, if we substitute, we're going to get pressure 1, which is 40, over temperature 1, which was 400 Kelvin, is equal to pressure 2 that we need to find, okay, over temperature 2, which is 200. Then we get that pressure 2 is equal to 200 times 40 divided by 400. If you do it on your calculator, you are going to get that pressure 2 is now 20 centimeters of mercury. Question number 12. Okay, here we are going back to what? To the GPE. We're looking for GPE. Do you remember the equation for GPE? GPE is equal to plus or minus mgh. Plus if it goes up, minus if it goes down. So here we have a student of mass 40 kg ascending. He's going up through 50 stairs, each of height 30 centimeters. So this is our height. They told us use g is 10 meter per second squared. Definitely, since he's going up, we're going to be using plus mgh. So his mass is 40 kg multiplied by the g, which is 10 multiplied by the height. How do we find the height? We multiply the 50 stairs times the height in meters. So 30 centimeters, you have to change it to meters. You divide it by 100. So if you put this on your calculator, you're going to have 40 times 10 times 50 times 30 divided by 100. And you are going to get 6,000 joules. But do they need it in joules or in kilojoules? They need it in kilojoules. So to change from joules to kilojoules, we're going to divide by 1,000. And you will get that it is now 6 kilojoules. So the answer over here is 6 kilojoules. Question number 13. Okay, how to know if it is a property, if it's a, thermometric property, or if it's not a thermometric property? Read and try to think about it. If it changes with temperature change, then it is thermometric. Okay? If it doesn't, then it's non-thermometric. So the volume of a fixed amount of gas at a constant pressure. If you increase the temperature, definitely the volume is going to increase. This is which law? We have a constant pressure. So this is Charles' law. Okay? As the volume increases, then the temperature will increase. So this is a thermometric property. Mass at the beginning of a reaction stays the same as mass at the end of a reaction. If you increase the temperature of something, will its mass increase? Definitely not. So it's not a thermometric property. Hardness of an egg. If you boil an egg, okay, at first it's liquid, then it becomes hard. So now this is a change in state. So you might think, oh yes, this works. But then if you cool the egg, will it go back to being a liquid? No. So since it does not go back to becoming a liquid, then it's not a thermometric property. Now definitely the last one, the length and the mercury in the tube. it's the same thing as the volume. So as the volume increases, the temperature increases, or as the temperature increases, the volume increases. So it's definitely a thermometric property. So this is thermometric, non, and then thermometric. Question number 14. Okay, now question number 14. A very, very important question. So this is showing the calibration of a Celsius thermometer. What does calibration mean? If you have a thermometer and you don't have the measurements, how do you find the measurements? We're going to use what? Calibration technique. What do we need in calibration technique? First of all, we need to have an apparatus. This apparatus is a beaker. Inside of this apparatus, what we will have, we will first have water. But they called it boiling water. Why? Because we're gonna add heat to it so that its temperature will increase and it will start boiling. When it starts boiling, what happens? Steam will be released. So this is called what? Steam at 100 degrees Celsius. And then the temperature will increase all the way. In the mercury, definitely in the thermometer, it will increase all the way to where? To the steam point, which is 100 degrees Celsius. So first you're gonna add heat, then the water will boil, okay? Then you will have steam, which is at 100 degrees Celsius, and then on the thermometer, this is what? The steam point. So that was question number 14. Question number 15 now. Okay. A fixed amount of gas is kept at a constant temperature. Anytime we see constant temperature, we say Boyle's law of 25 degrees throughout an experiment. The initial pressure, so this is pressure 1, is 1 atmosphere, and its volume, volume 1 is 12 centimeter cube. They told us that the pressure increased to 3 atmosphere. Notice how they didn't say it increased by. Only one word can change everything. They didn't say it increased by 3 atmosphere. They said it increased to 3 atmosphere. So this is now what? This is pressure 2. We know Boyle's law states that volume is directly proportional to the inverse of the pressure, or is inversely proportional to the pressure. So then you get the equation volume times pressure is equal to constant, and then we can expand it to form V1 times P1 is equal to V2 times P2. So by applying the law, we can definitely find the second volume. So first of all, they're asking us for the temperature of the gas in Kelvin. We know it's 25 degrees Celsius, so to change it into Kelvin, we add 273. So then 25 plus 273, it is 298 Kelvin. So over here it is 298 Kelvin. Now to find the final volume, we're going to be using Boyle's law. And definitely down there asking us to find the final volume. So what do we need to do? We need to substitute. Volume 1, which is 12, multiplied by pressure 1, which is 1, is equal to volume 2, which we need to find, times pressure 2, which is 3. Bring 3 to the other side. We will now get that volume 2 is equal to 12 times 1 divided by 3. So volume 2 is equal to 4. So now we know that the new volume is 4 centimeter cube. Here, this is Boyle's. Please pay attention for the spelling. Boyle's law and the temperature in Kelvin to the nearest integer. We got it, I believe it was 298. So it is 298 Kelvin. Question number 16. Okay, this is important. The initial pressure of a dilute gas is 8 atmospheres. Its volume is 12 centimeter cubed and the temperature is 27 degrees Celsius. Stop. They said for Charles' law, anytime we see Charles' law, we know that what is constant? The pressure is constant. And what two factors are not constant? The volume and the temperature. Why? Because the volume is directly proportional to the temperature. So we're gonna cancel anything that has temperature or volume. Cancel, cancel, cancel. This one doesn't have volume, doesn't have temperature, and it has pressure, which we know is constant. So definitely this is constant. Now they need us to find the volume, they need us to find the new temperature in degrees Celsius if the volume is increased to 18 centimeter cubed. So we have 12 centimeter cubed and 27 degrees Celsius. Okay, first of all, this is what? This is volume 1. This is temperature 1 in degrees Celsius. To change it to Kelvin, So temperature 1 in Kelvin, it becomes 27 plus 273, so it is 300 Kelvin. Okay, now this is volume 2. And we know that Charles' law states that volume is directly proportional to the temperature. Okay, so volume 1 divided by temperature 1 is equal to constant. Then we get the rule that volume 1 over temperature 1 is equal to volume 2 over temperature 2. Now, to substitute, we're going to apply this equation. Okay, we have volume 1, which is 12, divided by temperature 1, which is 300, is equal to volume 2, which is 18, divided by temperature 2, which we need to find. So temperature 2 is equal to 300 times 18 divided by 12. Okay, how did we do it? We did cross multiplication. So 300 times 18 divided by 12, we get that temperature 2 is now 450 Kelvin. But do they need it in Kelvin or in degrees Celsius? They need it in degrees Celsius. So to change from Kelvin to degrees Celsius, we are going to subtract 273. So 450 minus 273, we get 177 degrees Celsius. So this over here is 177 degrees Celsius. Question number 17 now. Okay, this is very, very important. Okay, we have two more equations that I'm going to talk about. We have that the average energy is equal to the constant times temperature, absolute, and we have that the average speed is equal to the radical of the absolute temperature. So we have to keep these in mind. Okay, over here, first of all, we have temperature 1, which is 300 Kelvin. The average speed, so this is average speed 1, is 1900 meters per second. They told us if the absolute temperature is increased to 1200 Kelvin, so this is what temperature 2, they need us to find what? Average speed 2. So we can form an equation. The average speed 1, okay, I will make the average smaller. Average speed 1 over average speed 2 is equal to the radical of the absolute temperature 1 over the absolute temperature 2. Okay, remember, the average speed 1 over the average speed 2 is equal to the radical of the absolute temperature 1 over absolute temperature 2. So if we're going to replace, we're going to have 1900 over average speed 2 is equal to radical temperature 1, which is 300, over temperature 2, which is 1200. So if you're going to do it, you're going to get that then 1900 over average speed 2 is equal to 0.5. So then, if you're going to solve it even more, you're going to get that 1900, okay, is equal to 0.5 times the average speed 2. Bring now 0.5 here, you're going to get that average speed 2 is equal to 1900 divided by 0.5. And if you do it on your calculator, 1900 divided by 0.5, you are going to get 3800. So it is 3800 meters per second. Now, question number 18. Okay, so now, a fixed amount of gas is kept at temperature T. Okay, the average speed of its particles B, so we have what? Average speed and the average kinetic energy, which is E. That means we have two equations where E is equal to the constant times the temperature, the absolute temperature, and that the the average speed is equal to the radical of the temperature. Alright, so now that we have these two equations, let's proceed to explain and understand. Okay, so they told us the temperature of the gas is quadrupled, so now absolute value of T becomes 4. So now if this is our equation, then we multiply this by 4, then definitely we have to multiply the other side by 4. And if this is our equation, and we multiply this by 4, before we proceed and do anything, we're going to do that the average speed is equal to radical 4 times t. What is the radical 4? Radical 4 is 2. So now it becomes 2 times radical t. So if you're going to multiply this by 2, then definitely you're going to have to multiply this by 2. So again, I will explain. Average kinetic energy is equal to constant times t. You multiply this by 4, you also multiply this by 4. So whatever you do to the t, you will do also to the e. However, for the average speed average, it's equal to the radical of the temperature. So if you multiply this by 4, you're going to do radical 4 times t, and then you will get that the absolute temperature is equal to radical 4, which is 2 times radical t. If you multiplied it by 2, then you're going to multiply the average speed by 2. So you multiply a number by t, you will multiply the same number by e. You multiply a number by t, you will multiply the radical of that number to the s. Okay, so we have here that it becomes 4e, and over here it is 2 times s or v. Sometimes they write s, sometimes they write e. So here it is 4e, and here it is 2v. V is the same thing as speed. It's velocity and speed, okay? Okay, so now this question is a really very important question. So please pay attention with me. The 200-gram bob. In physics, we never accept the weight or the mass, sorry. We never accept the mass in grams, so we have to change it to kilograms. It becomes 0.2 kilograms. Oh, a pendulum has a length of 0.8 meters, so we have a distance. Is it a vertical distance or a horizontal distance? Let's see. It's projected at 2 meters per second. 2 meters per second is what velocity, okay? Horizontally, so that means this is the horizontal distance. Distance in physics is horizontal. Height in physics is vertical, but to be honest, it's the same, it's the same everywhere. Distance horizontal, that means like this. Height vertical, that means like this, okay? From its lowest position, they told us take g is 10 meters per second squared. Anytime they ask you for the cosine of the maximum angle, this is what we're gonna do. In the pendulum, we have that, this is the pendulum over here, okay? And then we have that it swings either like this, or then it goes like this, or then it goes like this. Here in the middle, it has maximum kinetic energy. That means all the potential energy is converted to kinetic energy. At the sides, it has what? It has maximum potential energy. That means all the kinetic energy is converted to potential energy. So they told us the maximum angle the pendulum makes with the vertical. Anytime they tell us maximum angle, that means they're asking for the maximum potential energy. Maximum potential energy is when the kinetic energy is totally transformed into potential energy, and then we can say that kinetic energy is equal to potential energy. The only potential energy we ever learned in physics this year, this chapter, is gravitational potential energy. So very simply, our equation becomes kinetic energy is equal to gravitational potential energy. Okay? The rule for kinetic energy is 1/2 times the mass times velocity squared. It's equal to mgh. Substitute. Okay? 1/2 times the mass, which is 0.2, times v squared, so times 2 squared, is equal to the mass 0.2 times g10 times h. So like this, we can find h. So solving it, you will get 1/2 times 0.2 times 2 squared. You will get 0.4 is now equal to 0.2 times 10 times h. And then solving it even further, you will get that h is 0.2. Now this is very important. We know that this is d. D is 0.8 meters. And we found h. H is what? 0.2 meters. Anytime they ask us for the cosine of the maximum angle, our equation becomes 1 minus small over big. Then we will get what? Cosine of maximum angle. Okay, so 1 minus the small, which is 0.2, over the big, which is 0.8. If you do it on your calculator, you will get 0.75. So the maximum angle of the pendulum is 0.75. Sorry, the cosine of the maximum angle okay? However, if they asked you for the maximum angle, what you would do, you have now cosine max is equal to 0.75. They're asking you how much is max. Very simply, you do max is equal to cosine inverse of 0.75. Do on your calculator, shift cosine 0.75, you will get the angle, which is approximately 41 degrees. Okay, so that's question number 19 done. Question number 20. So, a force F is applied to a plank that can rotate about fulcrum A. Fulcrum A is then our axis, okay? We know that the rule for the moment is that moment is equal to force times distance. Here we aren't given any force, we aren't given any distance, so it's like a logical question. They're asking us for the moment of the force is directed in which direction. What you're gonna do is you're gonna take your right hand. You're gonna place your right hand on the force. The arrow is pointing upwards, so your fingers should be pointing upwards. Your palm, the inside of your hand, okay, the place where you see the lines on your hand, okay? The inside of your hand, your palm, has to be facing to the axis A. It has to be facing over here. And then you notice that your thumb is pointing towards you. If the thumb points to you, it is out of the plane. However, if the thumb points to the screen, it is into the plane. Okay? Out of the plane means counterclockwise and positive. Into the plane means clockwise and negative. Okay, sorry for the bad handwriting, by the way, because it's on the tablet, okay? So by doing the right hand rule, we notice that our thumb is pointing towards us. Since it's pointing towards us, or it's pointing towards me, or pointing towards you, then the direction is out of the plane of the picture. And since it is out, okay, that means it is counterclockwise, so it is positive. Now, the last question. Okay guys, so unfortunately my SDP lagged the last second, so I had to get someone to send me the question, okay? So anyways, we have a column crane lifts 320 kg. This is mass of construction materials going up 12 floors, and the height of each floor is 3.2 meters. So we can find the height in 120 seconds. This is the time. And then we have G, which is 10 meters per second squared. They need the power. So to find the power, very easily we can do work over time. So power is equal to work over time. Here the work is mgh. M is 320. G is 10. H is what? It is 12 floors multiplied by 3.2. So now the work is going to be 320 times 10 times 12 times 3.2. We are going to get a big number, which is 122,880 divided by the time, which is 120 seconds. So divided by 120 seconds, you will get 1024 watts. This is the work developed by the crane. So thank you guys for watching. I'm so sorry my SDP had to lag the last question last minute. And I hope you guys understood. Have a wonderful day and do good in your exam tomorrow.